This is Chapter 2, Section 2, Graphing on a Coordinate Plane. First of all, a coordinate plane is formed by two lines. The x-axis, which is a horizontal line. I'm going to use my ID card here to draw that. It's going to be a small one. So that's my x-axis. That's my horizontal line. And the y-axis, which is a vertical line. These two will intersect like this. So again, the horizontal line is your x-axis. The vertical line is your y-axis. They're just number lines. This side is the positive. This side is the negative. This upper half is the positive, and this lower half is the negative. When they intersect, they create four quadrants. Quadrant 1, Quadrant 2, 3, and 4. They intersect at the origin, which is right here. That's the point of origin. That will always be 0, 0, based on our ordered pairs from yesterday. This is your ordered pair, x, y. Remember, x is always moving to the right or to the left, and that will be your first move when graphing. Your second move will be the y, which is either up or down. Don't be afraid to use that QR code up in the corner if you want. So I'm going to move on to example 1 here. An air traffic controller stationed at 00 reports airplane A at 4:3, which represents 4 miles east and 3 miles north of her location. That would be right here. So east is to the right and north is up. She spots airplane B at -3, -2. -3 is the west, and -2 is 2 miles south. Airplane B, -3, -2. Now I have two dots. I have two dots on my graph now. Sorry about that. Let's do that again. This was A, 4, 3, and this is B, -3, -2. Now because I have two dots on my graph, I need to identify them. So this is plane A, this is plane B. Then there's plane C, which is 5.5, -2, which means 5.5. So again, 1, 2, 3, 4, 5.5 right underneath that X, which is east or to the right. And then it's 2 miles south. Okay, so that's a -2. So it's going to be a down. So -5, 1, 2. And there you go. Remember, everything we did was X first, right? Right, left, right. Then Y was second. Up, down, down. So now let's slide this a little bit more. So number 1A, using the same coordinate plane, that's this up here, graph the location of airplane D at -3, 3.5. Okay. Well, -3 means you're moving to the left, which is west. Then it's up 3.5. 1, 2, 3.5. And that's going to be moving north. So there you go. What does the location -3, 3.5 represent? I'm going to give you 30 seconds to think about that. It's very similar to yesterday with cars and profit. Each one represents something. Well, -3 represents a direction, which is west. +3.5 represents, if -3 is west, +3.5, which is your y, represents north. These are the coordinates of your plane. Alright, here we go. We have 2 more to go. Alright, so we're going to have to flip the page on this, but let's read the question first. How far is plane B from plane D? How can you use the coordinate plane to determine this distance? Alright, so now I got to go back. Put that sort of in the middle. So again, the question is, how far is plane B from plane D? Here's B, here's D. What can you do to determine how far apart they are? I'm going to give you 10 seconds to think about that, and I'm going to change the page afterwards. So you might be thinking counting. Some of you might be thinking, well, let's count. 1, 2, 3, 4, 5.5. It's not a bad way to go. So that is an option. So the coordinates of B are -3, -2. And the coordinates of D are -3, 3.5. So if you counted, you said that there are 5.5, and let's remember, those represent miles apart, okay? Like I said, some of you might have counted. Let's cross that out. There's also another option. Hopefully somebody was thinking that you could subtract, okay, the y coordinates. Let me put that here. So let's put a 1 there for one option, and 2. subtract the y coordinates. Let's think about that for a quick second. So your y coordinates are -2 and 3.5. If you subtract them, look at that. -2 minus 3.5 is -2 plus a -3.5. And that equals -5.5. So that's 5.5 miles. What do you know when an ordered pair has the same x and y coordinate? So they could be, let's say, 5, 5, or a negative example might be, let's just say -6, -6. There are no other options other than maybe 0, 0. So what do you know when the x and the y are the same? I'll give you 10 seconds. Well, there's only one option here. The answers, or I'm sorry, the points, the coordinates, can only be found in quadrants 1 and 3. If they're the same, they'll only be in quadrants 1 and 3. That's it. And again, 0, 0 is on the axis, so that's at the point of origin. But we're talking about values that are greater or less than 0. Alright, so we're going to do the rest in class at this point for practice.